So for the second example, problem states a single phase motor connected to 400 volts 50 Hz supply takes 31.7 amperes at a power factor of 0.7 lagging. Calculate the capacitance required in parallel with the motor to raise the power factor to 0.9 lagging. So we are solving for the capacitance. And again, I believe we have to draw the triangle here. So we have originally a triangle whose power factor is 0.7 lagging. Let's deal with that first. So if the power factor, the initial power factor is 0.7, then what is the initial angle? So it's inverse cosine of 0.7. What's the inverse cosine of 0.7? It's 45.573. There. Originally also it's connected to 400 volts 50 hertz. I guess those won't change, so I'll write them down here. So 450. There. And yeah, next it's taking 31.7 amperes. So I1 is taking 31.7 amperes. Calculate the capacitance required in parallel with the motor to raise the power factor to 0.9 lagging. So we now have a new power factor here, which is equal to 0.9. And if the power factor there is 0.9, then we could probably solve now for delta 2. This is PF2. Delta 2 obviously is inverse cosine of 0.9, which is equal to 25.8419. 25.8419. There. So let's check on this a bit. So originally, we don't have a capacitor. So originally, this was our diagram. We have a motor being supplied by a 400 volt source. It's single phase, I believe. Is it? Yes, it's a single phase motor. So 400 volts and 45.573 angle. Now, this one has a capacitor installed in it already. So this is originally our load, and we now have a capacitor here. There. Now, of course, our problem is going to be, first, we need the triangle, because this one originally has an angle of 45. If we draw it this way, right there, then this base happens to be the real power. Question is, can we solve for that real power? This one is what we know, 45.573. what are we given? We're given the voltage, which is 400. We're also given the current, which is 31.7. We're given the power factor, which is zero point 0.7. Of course, we can solve for the real power. So the real power here, just leave a space there, is equal to VI times power factor for single phase. So 400 times 31.7 times the power factor of zero point 0.7. There, that must be equal to, let me check, 400 times 31.7 times 0. 0.7 is 8876. So this is 8876 watts. So let me draw here 8876. Now ponder on this, guys. We need, or we install a capacitor in order for us to decrease the power factor, or increase rather the power factor to 0.9, so that if I draw this triangle, we are decreasing now the angle. We now have just 25. So this is now just 25.8419. There. My question is, what values changed? This is exactly what I was talking about on my previous video, wherein I was telling you about the values that are supposed to change from the previous diagram to the next diagram. So I told you it's going to be a case-to-case basis. If you recall your first example, there was no change in S, right? There was a change in P. There was no change in S because the problem states it's for the same kVA loading. Now, is it going to be of the same case for this example? And the answer there is no. It's not going to be the same. Why? Because the addition of capacitor here would mean to say that the capacitor does not have any resistive element in it. Approximately, it's just purely capacitive. And remember that real power is only affected by resistive elements. So there you go. If this is P1, what you must understand is that P1 is the same as P2 because apparently the only thing that have changed between the two is just the capacitor. We've just added a capacitor. No change in real power. So I will copy the value of P here. There, it's also 8876. They look the same. Their bases are equal. Now, if this is going to happen, you have equal base, but you have different angle. Something must have changed in terms of the dimension of the triangle, right? And you actually have two things that changed: the height of the triangle and the hypotenuse of the triangle. So which means to say the apparent power is not the same anymore, right? So they're not equal anymore. Also, the height is not the same anymore, so the reactive power is not equal. Why is that? Of course, because we now have added an additional capacitor for the second circuit to improve its power factor. So we are now being led to the equation that, or the idea that we have to write an equation which solves for the original value of q here and which solves for the new value of q. So for the original value of q, we have here an adjacent side given. We're solving for the opposite side. We have an included angle. Trigonometric function is tangent, right? So tangent 45.573 is q over 8876. Therefore, q is 8876 tangent of 45.573 equal to tangent 45.573 times 8876, 9055.3325. There. Unit is, this one is in watts, so this must be in vars. My neighbor's cat is very noisy. Next, for for the second triangle, so this is q1, this is q2, can only be solved, of course, similarly like how we solved q1. It's also 8876 tangent, only this time using an angle of 25.8419, which is equal to 4298.8367. So originally it's somewhere 9,000. Now it's 4.2. What caused the reduction in reactive power? Of course, it's the installation of this capacitor. And from these two values, it's very evident how we can now determine the Q that was offered by that capacitor. So obviously, must be Q1 minus Q2. Substituting the values, 9055.3325 minus answer is 4,756.4958 vars. There. So we have just solved for the reactive power that was offered by this capacitor when we installed it in parallel with our motor. However, that is not the final answer we are looking for, but it will help us solve for the final answer because we know that that Q is, it's single phase, right? I will change the color of my pen because I can. It's, that Q is, remember, it's the voltage. There's no such thing as line to line or line to neutral anymore because it's single phase, divided by XC. There. So it can give us now the value of or capacitive reactance, which will be equal to 400 squared divided by the Q capacitor 4756.4958, and this must be 400 squared divided by answer 33.6382. There, right? But still, that's not yet your final answer, because what we're looking for is the capacitance. This one is capacitive reactance. It's in ohms. So just a simple recall, of course, XC 33.6382 is equal to 1 over 2 pi FC. 2 pi. That is where the frequency comes in. A frequency of 50 multiplied to the capacitance. And of course, this should now be our final answer. So 1 divided by 2 times pi times 50 times answer is 9.4627 times 10 raised to negative 5. I do not like that form. I want it in micro. So 94.6275 microfarad. Ang dali, di ba? So, there.